In this video, we're going to explore something called the ambiguous case for the law of sines. So the ambiguous case is a result of having a side-side angle triangle. So again, we have two sides and their non-included angle that we're given. And we want to try and determine how many triangles can be formed when given this information. So we have this, using GeoGebra, we have this application that I can adjust the measure of my given angle and the measure of the side opposite my given angle to kind of outline these different scenarios and see what we get from those. So if our given angle is acute, we want to consider these four things. So here we have an acute angle measure, 51 degrees. So let's try and answer this first question. It says if side BC, which is the side opposite angle A, is less than the length of our altitude, how many triangles can be formed? So right now our side BC has a length of 4 when the altitude is 6.99. So a triangle is formed when this point B lies on this ray here, closing our figure. So if you recall, this measure, the measure of angle C, is not given. It's unknown, and as well as the length of this side here. And because those are unknown, they're variable. They depend on what our measures are elsewhere in the triangle. So because this is variable, this point basically just acts like a hinge that this side opposite our given angle can kind of rotate along. So if I were to take this side and try and make it so that it will hit the base here, we can see that it's never actually going to hit the base. Even if I make the value of A, let's say 6.6, which is really close to that of the altitude, we can see that it doesn't quite get there. It's a little short. It falls a little short of this base here and never actually closes off our figure. So if the side opposite our given angle measure is less than the length of the altitude, we form no triangle at all. What if the side BC is greater than the length of the altitude? And one thing that this doesn't say in here, but is important, and that it's also less than our adjacent side, how many triangles do we form? So let's make it like 7.5. 7.5. So if this length here is 7.5, which is larger than the height and less than the adjacent side, we can see that it will intersect this side, side C, forming side AB here at this point, and that gives us a closed figure and a triangle. However, this is not the only point where they can intersect, and this is why it's called the ambiguous case. Because it could either be a triangle that forms here, it's with sides 9, 7.5, and an angle 51 here, or this could continue and swing past this point here and intersect this same side, again giving us a second triangle with the same measurements, the opposite side 7.5, the adjacent side of 9, and this angle measure here of 51 right there. So there are two possibilities for the triangle, and this is why it's called the ambiguous case, is because when you have a situation like we do in point 2, we don't know which of these triangles it's actually talking about. So we have an ambiguous situation in this. Point 3 says if side BC, if this side is equal to the length of the altitude, how many triangles can be formed? So if it was 6.99, so right here, it's going to intersect right at this point. So it's going to give us just one triangle, and that triangle is going to be a right triangle. And that makes sense because that means that this side length is the length of the altitude, so it must be the altitude. And then number 4 says, what if the side opposite our given measure is greater than side AC? Well, if it's like 9.5, we can see that it's only going to form one triangle. It'll hit here, but if we try and swing it past to see if it will hit this side anywhere else, it's going to swing past the other point and won't actually close our figure again. So there will just be one triangle in this situation. So all of these occurred when our given angle measure was acute. What happens if our given angle measure was obtuse? So I'm going to reset this back to where we started and just adjust this to be an obtuse angle. So let's make it 115 degrees, 115 degrees. So this asks if our side BC, the one that's opposite our given angle, is less than the length of our adjacent side, how many triangles can we form? Well, right now, it doesn't quite reach the other side. It can't close this figure, so it's not going to form any triangles. And even if we make it something like 8.9, again, it's going to get really close, but it doesn't actually close our figure. And this is also true if it's equal to. If it ends up equaling 9, if it's the same, right? So that's what it says. If it's equal to, how many figures or triangles do we make? We're still going to make none, because what's going to happen is it's just going to be this same segment and doesn't actually form a triangle, just forms a segment. So if the side opposite our given angle is greater than the adjacent side, then we have one triangle. And there is no way to possibly form two triangles in this case, because if we had a side length that was long enough to actually reach this side, when it swings back to their side, we're never going to hit it again. So there's only one possible triangle when we're dealing with an obtuse case, and that just requires that the side opposite our given angle is longer than our adjacent side.